Fantastic. Questions from the audience? Yes, sir.
Yeah, so good evening. My name is Cal Ross, and I'm a management consultant in the supply chain services domain. And firstly, thank you for taking the time tonight to share your wisdom. And so, Andrew, your example earlier on the food supply chain, really I could relate to that. And so coming from a supply chain business background, trying to get an understanding of the big data concept to see if it's really a passing fad or is it real. Now, was there a trigger point that, because if I understand correctly, the big data, data intelligence, business intelligence has been around for quite some time. So was there a trigger that caused the big data hype to really take off, or anything that happened that caused this to really, everybody talking about it? Was there anything that you think caused it, or is it for here to stay, or just trying to get a feel of that?
No, I mean, so I guess I was kind of working at Google before big data became a term, and I've actually been involved in it for a long time. It's more of an evolution. I mean, if you look at, I was in Silicon Valley for almost 20 years, and if you look at the cycle, we moved from, it was very hardware-centric, and we slowly moved up the stack to, okay, so it's not so much hardware as now it's, the software, and then you go where it's the data, and, the algorithms. And we keep, it's an evolution and a level of abstraction. And the data, to get real technical, contains the algorithms that are interesting and the patterns that are interesting. We just have to figure a way to tease it out. In the specific case of, that the supply chain and the agricultural commodities, I got introduced to that mostly because I kept on running into it in so many places where I'd be approached by people who have these really interesting problems, but their problems were narrow. It's like, the commodities trader that wants to understand why their futures contracts and spot prices and hedging risk, it's becoming very expensive to hedge risk because the variance is so high. So that was their problem. Then I talked to, one of the global conglomerates who actually approached me, who they were, there's an interesting story. They got burned in 2008 by a typhoon that hit Madagascar that wiped out the half of the vanilla supply, because a lot of the world's vanilla comes from Madagascar, and they're a big buyer of vanilla. Well, their people on the ground had originally told them that their estimated losses were a quarter of the crop. And so they're like, okay, we understand kind of like the loss and what we expect. So they were fine, it hit, and of course, it actually wiped out half the supply chain, or half the supply from Madagascar, where their contracts were, but they didn't know that. Well, their backup supply was in Uganda. So they're like, okay, a couple weeks later, after they realize they're not going to get anything out of Madagascar, they go to Uganda. Well, because the people in Uganda are much closer to Madagascar, the local prices there went up tenfold. So suddenly there was looting and theft of all the vanilla because it was worth so much, like $1,000 a kilo or something. And so it was gone. So by the time they got to their backup supplies in Uganda, it had already been looted. So instead, they're like, because they consume this regularly, it's a part of their business. They go to Mexico, and Mexico has very expensive vanilla. It's very high-grade, people like it, and they signed very expensive contracts to get Mexican vanilla because they needed vanilla. Well, these are like weeks are passing, and many days are passing, and by the time that they actually signed those contracts, well, then it turns out the Ugandan government cracked down, all the stolen vanilla was put back, the price plummets in local markets, and they ended up over this few-week period losing $120 million because they were basically just going on what they thought was happening, and they weren't measuring what was happening on the ground. And that happened over and over and over and over again, and that was what really drove them to go, you know what, it sure would have been helpful, the data's out there, right? And they looked around, yes, the data's out there, there's just nobody collecting it and putting it together and synthesizing a model that lets us understand what our kind of real-time risk is in the vanilla market. And there's been more and more realization of that in many markets, not just commodities. It's a really good one because it's one where they kind of really understand right now that it's a global market and that there's a lot of global risk. But it's now it's getting into things like airlines and insurance and a lot of boring heavy industry actually that isn't sexy to a lot of VCs, but there's a lot of interest in doing some very sophisticated big data work in those spaces, but you have to understand the domain that those businesses operate in, which isn't always widely available knowledge in the kind of the startup community, because a lot of the people who do startups are not people that came out of, you know, some 150-year-old kind of boring commodity industry company.
So there's hope for those of us in boring industries. We have a question back there, sir.
So what is the time window for this technology before VCs get obnoxious and start hating the term big data? Already some of them are saying it. So,
Dina.
Oh, that's probably a question for you. I don't know. I still like it for, now.
Here's a question for the panel. If you had to use a new term, right, because some people are saying, gosh, big data, the sort of the eye roll happens on the term. What would you change the term to be?
The right data.
Smart data.
Smart data, yeah.
Yeah, I mean, I would, because I'm again, more of a platform guy, I would almost say, I mean, the problem with big data is that it means everything and nothing now. And so what, I mean, I see happening is that to clarify differentiation, we talk about exactly what we do. We don't kind of like, we don't say big data, we say we do this. We do, real-time sensor fusion or something like that that says what value specifically we're bringing.
Yeah, valuable insights, right? I mean, that's really what, I mean, if you can get insights out of it, you're delivering value to your customers, delivering value to your marketplace, and ultimately your investors.
And I think the point that venture capitalists in general, they don't know what you mean. You say, I'm a big data company. Well, everybody's come through saying this these days. So specifically, what do you do and how do you segment what you're looking at in the market is very useful to them. They've all tried to make these maps of big data, and they're all a mess right now. And there's a lot in there, which is a really good thing long term. But if you're trying to get someone to help understand what you do, be as specific as you can with your technology, your vision, et cetera.
I would put the word I, find the term that has the word I in it, like iData or something.
Yes.
Hi, so I heard you talk about sort of the catchy side, business-oriented analytics space of big data. I'm curious if you have any insight into the boring aspect, which has to do with the big data problems, telemetry, et cetera, that have to do, which is the operational monitoring of systems at large. I mean, some of these problems are being cast as big data problems as well. They just don't capture people's imagination because they have nothing to do with tweets and everything to do with log files.
Well, I mean, there's one that's smart grid. I just saw a stat that said the power industry really analyzes 0.5% of their data.
Yep.
And so it tends to be the trailing edge of technology. But I think these sorts of sectors are really ripe for innovation. They could sort of leapfrog since they've been very hardware laden and very old school. I think they have a lot of data, and I think the whole Internet of Things that Cisco's been, or Internet of Everything, I think, sorry, I read $1.5 trillion a year opportunity, is around this, the sort of latent pent-up demand in these industries that haven't seen big technology advances since the Tesla coil.
I think, so GE put out an incredible paper, if people haven't seen it, about the industrial era meets the internet era coming together. We sort of coined the term industrial internet that a lot of companies are now using. It's a fantastic summary of that whole opportunity, so I'd encourage you to take a look at it. I agree with you, there's a lot to be done there.
Yeah, but, and I would add, as entrepreneurs, though, I think it's always noble to go into industries that are like late breaking or hard, but keep in mind, these are going to be your future customers, and if you can't, if adoption is like a multi-year, multi-decade process, then you've got to be in it for the long haul.
Yeah. There's actually a lot of work that has been done, like log analysis, anomaly detection, but it doesn't tend to be it's not glorious enough to make headline news. But actually, there's a lot that is actually being done.
With your question around operations, like operations of big data.
So I see, if I may, right? I see analytics as having two sides, right? It's the analytics of the business I sell, and the analytics of how I'm running my business, right? With the complexity of running your business as it grows with the complexity in analytics, which goes back to your point, right? Log analytics, prediction, etc. I was just curious to hear exit strategies like you talked about. You talked about decades, etc.
Yeah, Yeah, there's a lot, like, I mean, one of the really useful applications for deep learning is yet another buzzword, is actually has been the log analysis. And there are a lot of sort of strides that are made in this space. But they are, as I said, they're not like, they're not flashy type of news, but it is making it to the space.
But I mean, you look at the leading log analysis company, Splunk is trading at 19 times revenue, $3 billion market cap on 200 or so million in revenue. Certainly one of the more, from a investment perspective, very sexy outcomes, right? And Similogic, they're all coming by. I think Splunk was founded 10 years ago. You look at, you guys are going to analyze log files? Be prepared for a slog, but that slog did pay off. And that's what I think Andrew, you had mentioned the whole dormant data problem. I think there's a company just raised a whole boatload of money in New Hampshire. I think Data Gravity, I think is their name, and they're going to index disk drives and enterprises. They're going to crawl. How much information is on your disk drive that you've long ago forgotten, and so there is dormant data there that is valuable and not sexy maybe, but not yet.
Right. Other similar problem, I think the classical problem is user retention. You're offering service, you have a set of users, and you want to make sure you retain your users, right? And so you monitor their, that is a classical. And again, seeing actually there are great improvements in this space. Again, thanks to big data and sort of investments in machine learning, but not making kind of news.
Can we go with the gentleman in the yellow shirt?
Thank you. Ahmed, I have a question for you about technology. I come from the speech world, and we're seeing the hidden Markov methodology running up against the wall. Neural networks perhaps starting to show again a little bit of promise.
Yeah.
Could you give us your view of what technological horizons there might be to go beyond current status?
Yeah, absolutely. So actually speech is very interesting. So speech is an old discipline, as you probably know. It's, I don't know, since the 40s or something like that. And the speech, so I'm not a speech guy, and I'm going to maybe poke at them and poke at people like you. So HMMs was the sort of, hidden Markov models was the sort of the most common technology used there, and then I think we switched to Gaussian mixture models. And so it has been a very, very well established sort of discipline for a long time, and over the past maybe 5-6 years, there has been fairly little improvements there. Until really deep learning, which is, deep learning is sort of, is the third coming of neural networks to sort of, the machine learning space. Neural networks appeared in the 40s or 50s. They went out of scope, due to some sort of certain influential people publishing certain papers. They went out of fashion. They came again out of, back in vogue in the 90s. They went out of fashion again. They came back in the early 2000s due to work done by Jeff Hinton of University of Toronto. Basically, he found ways to actually train neural networks with very, very large amounts of data and with models that mimic the brain in many ways. The brain is believed to have so many layers of neurons that basically operate on raw signals like pictures, like speech, like words, and instead of humans inventing features, they tend to do their own feature extraction. And for domains that have been really well established, like speech, we're seeing right now results that are actually, leaving these results in the dust. So the improvements that happened in speech recognition over the past maybe 1 or 2 years are more than what happened maybe in the past 6-7 years, right? So, and that's referred to, sort of in the industry as sort of deep learning. We're seeing that in computer vision as well. We're about to see that in natural language processing in certain types of problems. So the problem with deep learning is that actually it requires processing of very, very large amounts of data. And requires lots of, the models that we're talking about are really big. We're talking about tens of billions of parameters that have to be trained. And also back to the point that I made earlier, actually machine learning algorithms were not ready for the most common used algorithm is stochastic gradient descent. It's actually not ready to be used in parallel. So people are really rushing to find, Google published this paper, I'm sure maybe some people in the audience have heard about it. It's often referred to as the cat faces sort of paper. They trained their deep learners on YouTube images and videos, automatically people's faces, and also on the side they were able to find cat faces, without actually teaching the system. So they're starting to look like a brain, and they literally have a brain team over there. And this technology is making it to search, it's making it to online advertising. With Microsoft, we have fairly similar investments. Can't talk about most of them, but this technology is making it actually to many of actually our offerings, and completely taking the state of the art in certain technologies like speech and computer vision to new highs.
One thing I'm starting to hear from marketers in particular is dashboard fatigue. So there's using so many big data systems, and everyone gives you a different dashboard. It's supposed to tell you something. And do you guys have some thoughts on what that means for big data as an industry?
Yeah, so we're definitely seeing trends of workflow consolidation. And workflow consolidation, to the extent that marketers can use a single tool, they want to do that. Definitely system login. We hear about login fatigue too, which is, I have to log into my data management platform. I have to log in now to my ad execution platform. I have to log into my mobile execution platform, and keep going. And so we're seeing a lot of workflow consolidation happen. The way we envision it happening is there's going to be workflow consolidation around data management, and then workflow consolidation around execution management. To the extent that those two things become one will take time, but they're right now very different. They're different enough where I think they'll stay separate. And then in terms of the dashboarding, frankly, what we're finding is our marketers, they don't want us in the dashboarding business. They want us to bring in the data, normalize it, tie users together, and they want us to spit it back out. And so, each company kind of has whether it's their proprietary systems or even systems like Tableau, where they have, 30 analysts sitting around wanting to crunch data. But they want us to solve kind of the core big data problems around data collection, data, tying data together, data normalization, definition, and then extra. So that's kind of what they're asking for. Is just do the hard part, do one of the hard parts, and let me get it out, let me find something, and let me then put it back in. And it's that closed loop. But great question.
Yes.
So one of the more visible examples of big data in popular culture is Nate Silver's election forecasts and sports analytics. Can you talk a little bit about examples of big data in entertainment and sports industries?
The worst popular culture.
Our panel may not be,
Data's there.
Again, recommendation engines. I mean, Genius, Apple's Genius, sort of, if you have an iPod, or and that is essentially a big data sort of machine learning component that is trained on big data. So recommendation engines are making their ways to, if you shop on Amazon, if you buy movies or rent movies from Netflix, you're using the recommendation engine. This is all in the entertainment sort of industry and movie industry. What other examples?
One of the things, example I used earlier was, right now Twitter or any social chatter is not demographically split. So you don't know who's saying what really. It's a trending topic, but you don't know what certain segments of the population are talking about that topic. So I think you're going to see some of that where we have a public profile for everybody in the United States, certainly in most of Canada at this point, and we have a growing set of profiles that have Twitter handles associated with that. So you could then take the fire hose from Twitter and get a sense of what different constituencies, what different segments are saying, and what they feel about certain popular topics in the news. And I think I'm really excited by that. It'll be relatively anonymized, of course, but it'll give us a sense that this fire hose is actually just an amalgam of a lot of little hoses, and I think that'll give us more insight into the world of social chatter.
Another interesting interesting example that actually just came to mind is in soccer, where they are now, especially in the upper leagues, fully instrumenting, for all intents and purposes, the individual players as they're playing in competitive matches. And there's been a really interesting case, it's starting to propagate out, where I believe it was Manchester City actually put their data set of all their players online. They said, they basically did a Netflix thing, they said, here, analyze it, show us interesting things of all the sensing data they were collecting from their players as they were playing competitive matches. And I think that's a really interesting way also to bring like fans and enthusiasts, into the game, as well as providing useful insights for the club management.
Yeah, has anybody seen the movie called Moneyball? So that's there you go. That is, this geek was actually cooking is probably using some form of machine learning there. Logistic regression, who knows, yeah.
So before we started, a few people in the audience asked about so big data meets this mobile revolution and location-based services meets cloud infrastructure. How does this come together? What happens?
Yeah, mobile is interesting. Yes. So mobile is this sort of, people have been talking about mobile for a long time, and that it's this next sort of big thing. And it's actually, look at, I think Google is saying that maybe half of their advertising revenue right now is coming from mobile, and or something close to that. But it's tricky. It's actually, problem is most people have been dealing with it as, okay, we're really doing desktop stuff, but let's tweak our model a little bit and make it work on mobile and add sort of a few extra features here and there. But I think actually that strong approach is essentially a very, very different model, and actually has to be handled in a fairly different way. The kind of ads or advertising, the forms of advertising that are there, the kind of traffic, like for example, a big percentage of mobile traffic in search, guess what, they are local, right? So, just the distribution, the query distribution there is fairly different. Actually, the demographics of the kind of people who actually use mobile and do queries there or would use social media is fairly different from. So it has been elusive from that, and it hasn't really delivered on its promise from the sort of the business standpoint yet. But it's sort of this lurking opportunity that is about to sort of explode at some point in time. I hear that Facebook's growth number of unique users kind of asymptoted in the desktop space, but actually still going up significantly in the mobile space, sort of dramatically. So it's an emerging sort of space, and people are expecting a lot from it, but still hasn't been figured out.
Let me just echo some of the point I talked about, because I think that there is, every time that we shrink the technology from desktop to mobile to Google Glass, and I think we are assimilating this technology, which actually dovetails nicely with the deep learning aspects. As we are, the question is, for those that are Blade Runner enthusiasts, are the replicants coming, or are we going to become the replicants? And I think it's an interesting thought, because I think every time we do assimilate some of this technology, the game changes. And it's not just small desktops, to your point. It's transformationally, qualitatively different. And Google Glass is going to be completely different again. And we're already talking about how do we deal with the social values of do you know you're being recorded or not, or some of the privacy concerns around Google Glass. We are just starting to grapple with them. And then what happens when someone can just implant more pattern recognizers into your brain, and just, sort of that movie Limitless, I think, with Bradley Cooper, where he just takes a pill and gets really smart for about 12 hours.
Those will be available after.
Yeah, that's right. This sounds like it's very science fiction, but there is this acceleration that's happening, and I think as technologists and entrepreneurs, it's really exciting. But I'm of this dilemma that the technology is advancing exponentially and wisdom only linearly, and that really concerns me. And I think it's important that I want all of you to start thinking about these issues deeply. How do we get wisdom to accelerate at the same rate of technology? And maybe we do need to assimilate this technology to do that, to actually grow our wisdom as fast as we grow our technology. It's a challenge that's coming sooner and sooner.
Andrew, tell us about location, mobile, integration, everything.
Yeah, so, I mean, I think the way mobile is separated really, I like that way from the desktop to the mobile devices, that it really forces upon us this thing where, I can't look through and choose what I want, tell me what I need to know. It's just, it's more putting more of that, emphasis on answering the question instead of showing me things I should be looking, forcing me to ask questions. This also goes back to dashboard fatigue. It's much the same way. People are like, okay, too much stuff and I'm required to do too much work. Tell me the answer I'm looking for, as long as I can figure out a way to express it instead of making me get halfway there with this big display and showing me a bunch of pieces out of assembler. And mobile space, I think, is very much like that. The challenge in the mobile space is that one of the ways you get around forcing people to interact so much to get what they want out of their, have their preferences or desires understood, is that you have to compensate by taking much more context into consideration. And that works really well on mobile devices to the extent that they are kind of mobile sensing platforms. So you can understand, the data from where you are and what's going on around you. You use many, many other data sources to kind of build these kind of contextual models of what is, when this person, is here and they came from there, what do they really mean when they use this, do this ambiguous query, based on what I know about them. The way a computer might look at that. And I think, I think those are some of the challenges. And just, in that space is actually this, at my company we call it immersive analytics. The idea of, it's not just, looking through the keyhole, it's like standing in the room, everything around you, you can kind of say, I'm here, you can look this way, you can look that way, and you can actually take in all the sights and sounds and smells and whatnot that, kind of inform what a person is thinking or what they might want and so on. So,
And Dina, how do those trends affect marketing specifically?
Yeah, there's a couple very specific problems that we have to solve and, solve within the next 6 months. And that is, one, statistical IDs. So we need to be able to anonymously identify users with reasonable precision, without being able to drop a third-party cookie, which is kind of the technology of choice on desktop. And it's not an easy problem to solve. It results in fragmentation, user fragmentation, meaning that we think of users 2 and they're 1, and collisions, which is the opposite. And it's a big kind of data problem, and it's a data science problem, and then for marketers, it's all about cross-device mapping. You should take the context of the device into effect. So definitely, mobile-specific analytics are very important. Knowing demographic on mobile versus desktop, all of those comparisons are important. But then, not being able to tie it to users' activities on their desktop and then on their social network, on their tablet, means that a marketer who then lose the full 360-degree context that makes you that much more effective. So those are the two, at a high level, kind of the two specific problems that have to be solved.
Just to add local, since we have, so local I think has been underutilized so far. I think my diagnosis to that is that the being very careful with privacy has been one of the reasons. But like Groupon, I guess it's not a very good example, but it was an attempt to sort of delve in the space, and if it actually showed anything, that there's actually room to innovate there, and there's actually something to tap in from the business standpoint. But it has been so far, I think, underutilized. I haven't seen really anything, any sort of innovation or a startup idea, maybe Foursquare or something like that, but I don't think it's impressive enough. But I think it's waiting. It's waiting.
My assumption is that most of the interesting data is probably hidden behind, government systems or behind enterprise firewalls. So how can big data provide insight if it can't get at that hidden information? So how do we know what we're getting is actually, useful or insightful if only half the information is available?
Yeah. I can say something about that. So I'm sure you guys can add. So I would also add not just the government data, but social data. So much of the social data that the feeds that we generate, the comments that we make, the posts are totally out of scope for search engines who cannot index your social content, right? And there's just valuable information there, that can be, there's something that is stated on a post in Facebook that could be a much better answer for a query that I would make, right? But it's not accessible to search engines. So there's a lot of information, data that is proprietary or out of scope of the, I think aggregation is the, if you do proper aggregation and it's principled and rigorous, you can still get some, the value of the gems of this data without actually jeopardizing the, the PII or the privacy issues. And in the sort of academia and the sort of in the research community, there's a lot of work in this space. There's this incident about AOL that you guys remember. There is some data that was aggregated. Forgot the data was all about. I think about internet usage. And some people were able to, sort of reverse engineer the data and identify certain individuals and what kind of queries that they make, because the aggregation was not done in a rigorous or principled way. So it was possible to reverse engineer it. And that's actually what's hindering people from releasing data. But these problems are being solved, and soon enough we'll be able to access this data without jeopardizing privacy or sacrificing sort of PII issues. So I think that's the right solution to sort of leverage the data without actually hiding the aspects that we want to hide out. But it's still waiting for one or two sort of breakthroughs in this space, in the security cryptography sort of space.
Yeah, I actually do a lot of work with this actually with national governments on releasing data. I actually have a fair amount of, I actually learned a lot in the process. There's kind of three kind of issues that's why, and these are challenges that need to be solved to really get at that data you're talking about, because much of it is technically public. You just can't get at it, and nobody has it. One of them is that, as a practical matter, it's nobody's job to deliver, to make that data available. It's like they have the data, it's sitting there, it's a big pile of data, but it's no one's job. And so there'll be someone at USGS with a data set that lots of people want, but they don't answer the phone because their job is to do something else. They just happen to be sitting on the data set even though it's public data. That's one challenge. Another challenge is something actually related with Dina said earlier about this exponential growth and the rate of growth of data. There are now data sets that are growing faster than we can practically backhaul copies of them anywhere else than from where they were collected. And that's a very long-term, big issue that is never really talked about very much in big data, where there's already data sets, because storage grows faster than bandwidth to move around. And this is creating problems that even for a lot of data sets, it's not happening quite yet. Just give it a few years, and we'll be at that point for those data sets as well. The last one, especially for government data, is provenance and misuse and custodial kind of aspects. This was it turned out I was doing some work for the UN, and one of the things that really freaked them out was the idea that they were putting out sensing data that was nominally a representation of the planet or whatever, some event, and that this sensing data could be spoofed, misused, modified in some way that would cause actionable kind of events to occur based on this supposedly official data, and then that would be a bad thing. And there was data sets that were never released solely because there was uncertainty about how you could have chains of custody to a reliable repository such that someone didn't modify the data and cause multi-million or billion-dollar meltdown somewhere by people reacting to this official data. And I think those are all kind of like concerns that don't get raised very often, that it actually explain a large portion, especially in government, for why the data is not more readily available.
Most all the examples I've been hearing have to do with organizations, governments, companies, and down to the lowest level entrepreneurs, and trying to come up with applications of using big data. Do you at all foresee the point in time when all of a sudden the big data will become the tool of the individual? That the individual will then have like an internet teleassistant go out there and seeing in developing intelligence?
I could start on that one. Yeah, I do, actually. And we've been working with some groups to, and this gets to this idea of notice and control. And I specifically didn't say consent, because if you have control, that actually does embody a level of consent. And it actually would, I think, require a change to the fabric of the internet in some sense. Because see, what tends to happen, take the notice example. The trouble with notice often is that every time you turn around, you get noticed. Things pop up. Did you know? 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 And it degrades the experience so much that users just turn off. So if you were like to lay a policy on the internet that says, hey, we all need to be noticed 3 times every 6 months on maybe third-party cookies or something. And it wasn't on any specific company to notice you. There would be an API or an application would dip out and say, hey, has this individual been noticed? Yes, this person has been noticed enough for this period of time. The same thing on control. Say there's certain pieces of information that are about you that you really, in my experience, we deal with victims of domestic violence quite a bit. The biggest issue that they have is the latest contact information. That's the most safety-sensitive piece of information. The rest of the profile, they actually don't want it to disappear, because then it tips off offenders that someone is really trying to manage their profile by disappearing. They just want the trail to run cold. And so, wouldn't it be nice if there was, no matter where you entered the internet, whatever app you entered and started to use, you could execute those privacy controls there. And they would be syndicated and federated throughout the internet, so any other application that used it would have to honor that. That totally spreads the burden. And it's a better experience for the user, because they can do their controls at any place. I think that's coming. Because right now, the way the internet is, and privacy and advertising and the value that is delivered to users is really not appropriately accounted for. And I think that's going to change.
Yeah, I mean, I think local glass is the exact example that will be an individual use of big data that right now the overhead for an individual to give all the data inputs to make kind of all of these tools and things useful is hard. I mean, it's siloed. So, yes, my Bing knows me pretty well, Yahoo knows me pretty well, Gmail knows me pretty well, but who knows my life and can impact my life. The overhead for me to input all that data somewhere to make that effective is hard, but something like Google Glass solves that. And that, if anything, is just it's like a data collection, just amazing data collection mechanism, which is like, oh, she just woke up and checked her Facebook and checked the flash sale on Guild and is doing this and that, and can tie all the variety of data that I interact with every day, make it into a useful experience. I mean, it's much closer than I think we expect.
Great example. We have just a couple minutes left. So questions that exist in the audience. Yes?
So we hear a lot about data mining, data operations on data, but I have a different question. Do you see any? It's probably an Andrew question. What kind of problems you are facing in experiencing with respect to transport of these transport and aggregation of the data from the point of collection to the cloud or wherever this data is collected, and what do you see? What kind of burden is that adding to the solutions that you guys are developing, specific market applications?
Yeah, I mean, that's a good question. Part of it is what I touched on earlier, where because the data is growing so fast, as eventually for most of these, like a lot of really interesting sets and data sets, there will be exactly one copy. There has to be one copy. There's no way to kind of move it around so you can have multiple copies. But even at that, at that point, that doesn't scale well enough for a lot of data sources possibly available now, but definitely available in the future, where you still can't move that copy to one place. So it's not like we have one data center and this is the copy. It's where you have to federate the copy or federate the data to actually match kind of how it's distributed in reality, to be able to actually execute your operations, your analytics, your data mining, whatever, in a geospatially federated kind of model. And we're still, from a technology standpoint, it's still very early in, kind of like in being able to do those kind of federated models in a reasonable way. And on top of that, you have the whole legal aspect of, once you have a spatially federated model, you are now in several different legal jurisdictions that are going to modify how you can use the data that's kind of in your different nodes of your distributed database. It's a challenge, and it's still very much an open problem.
Other audience questions? Yes.
I work for AT&T as a product manager over there. The data, the amount of data operators alike over period of time is huge. Just think, right, we have like 16,000 SMS messages, but we cannot even snip that. We cannot even think about that. Whereas Google, they can go back and start looking at all your emails and give the context based on ads like that. So the reason why we are doing that one is FTC, strong FTC regulations on that. Since big data is going to play a key role, do you foresee FTC is going to change their regulations, or the federal government is going to come back on both big data and...
I'm sorry, I didn't see the question properly.
The question is like, do you see that FTC is going to change their stance on this one?
FTC predictions.
Have you seen the Google ads?
Yeah, I saw that one too, yeah.
Yeah. That's actually a fine line. I think this is if there's such a thing, an under-regulated sort of industry.
Yeah.
And this is, we're the US, we don't like to, we like things to sort of self-organize themselves, sort of in a market economy like. But I think there's a lot at stake here in terms of business, in terms of privacy. I think there has to be some kind of concentrated effort to actually introduce some litigation to organize things. That's at least my view. But this is a point I'm sure that not everybody's going to agree on. Yeah.
Because if you have small data, you cannot make meaningful hypothesis on that. And gathering the entire data in a single point is also a big challenge. Because once you have like huge data, then we can make a monopoly, and FTC is going to jump into that. So it's kind of like a problem how to solve that.
Yeah, and one of the unintended consequences is that because, those are very valuable data sets that a lot of people are interested in, and because they're so controlled, detailed, get out, there's, a lot of companies are finding very creative ways to basically get the same data by other means. Which at that point, because it was perhaps too regulated or too controlled, it encouraged people to find ways around it, which possibly makes it even less controllable than the original intent.
So Ahmed, can you kick us off with final comments, your pearl of wisdom on big data, and any advice for a budding entrepreneur?
Actually, I've been dying to say this for so I'm glad you asked me. So there are really 5 disciplines to sort of, big data. And if you're a startup, I would, try to master or be sort of really proficient in 3 or 4 of them. There is the data pre-processing or data sort of cleanup. Often data is very, very messy, and you have to deal with it, missing attributes, noise and stuff like that. There is data storage, sort of the big table, the DynamoDB sort of aspects, getting experience and, proficiency in this space is very important. Machine learning and statistics is a really key component in this space. Distributed computing, sort of Hadoop, MapReduce. Then visualization, which is often not mentioned. There, sort of pictures, worth I don't know how many words. Being able to articulate what you want in a sort of a fairly visual-friendly way is worth a lot. And visualizing big data is a big challenge. So these are the 5 areas that I actually see. If you're a startup in this space, I think you need to be fairly proficient and good and strong in 3 or 4 out of these.
Great advice. Tina?
Yeah, I would say a couple things. One, start with the end in mind, which is find a problem to solve. Find an industry and find a problem to solve. Don't get hung up on the technology.
Yeah, I'm actually going to say something in a similar vein to what Dina just said, is that, we focus a lot on the technology stack and about, I'm going to build this infrastructure with this many processors, and we're going to do this map-reduce process, and we're going to apply these statistical models or whatever to get our result. And the real bottleneck in, I'd probably say most industries, is that a lot of what we call data scientists are basically computer hackers who kind of moved over into doing data modeling, or they decided to go play with the data or do statistics more than they wanted to, program, write code or something. Although there's a lot of code involved in being a data scientist. But what's been really kind of stymieing many industries is domain expertise. And we really undervalue right now domain expertise in the big data market. People who understand the, what's really going on in this business and what all these pieces of data actually mean and how they relate to each other. And some of the dynamics of how, when this data changes over here, it's going to have an influence on this data over here. And so, because so many of the data scientists come from a very pure computer science-y type background, or from traditionally very technical industries, you have a lot of opportunities in industries that are more traditional, that really do not have anybody providing a solution or a platform where the domain expertise of that industry is embodied in a big data solution, where it's not so much about the technology, it's about understanding the domain in which it's being applied to, and people or companies who can bridge that gap. There's a tremendous opportunity for them.
So I would make a couple points, just to riff off of my fellow panelists. I think there's a data scientist is sort of a unicorn, right? You can't really identify who these people are. But they do have sort of three components. They are hackers, they do understand statistics, and I think the embodiment of subject matter expertise in solving a customer problem, I would say they're good storytellers, which ultimately I think links directly to strategy and customers. And so I think you have to sort of bring all these things together, and so that's why I think pure technologists or pure statisticians or pure storytellers don't really make the grade. They have to be pulled together. On the technology side, I would make the point that, yeah, big data is important, but the insights often come from small data, which I think, Dina, you've made that point several times, is that, get the insights. The actions that you may need to take based on those insights, you may need the entire corpus for. But I've noticed that some of our best successes have been just pare it down to a small amount of data, understand what's going on. Once you do, the rest actually is quite easy to write your MapReduce job, run on the whole corpus, and figure out what actions you need to take. But jumping to the big data immediately often leads you down a yak shaving exercise of chasing ghosts. And the last point I would make is this idea of responsible innovation. And I think as technologists, I really can't emphasize that strongly enough. We have a responsibility to use this technology in wise ways. And that means just because you can do it doesn't mean you should do it. But it doesn't mean you shouldn't do it either. You just need to have a process. Go talk to your toughest critics. Go talk to the people that think what you're doing is evil. Talk to them. Listen to them. Sometimes they're way off base, but at least you've actually grokked what they're trying to say. And this example I gave of knocking out your latest contact information, we didn't think that up. We got that from people who disagreed with us. I think that's really important, and as stewards of this technology, we have a responsibility to how it's going to impact our society.
So I'd love to end with a quote from Bill Gates, who was recently asked about big data in a talk that he was giving. And he said, big data is really telling us that the sky is the limit here. Would you like to learn from any set of data? And I'd like to thank our esteemed panelists, great set of experts that Ty brought together, and thank Ty for holding the event, and thank all of you for your time.
I think this panel deserves one more round of applause. So one more round of applause. So I want to really thank all the panelists, for bringing about such a fantastic discussion. As Ty is already being talked about thank all the volunteers and our mentors to help guide this event. So one round of applause for them. Last but not the least, we had a very fantastic audience. We had very interesting questions. So one round of applause for all the audience. So with the last note that we have upcoming events on 9th of April, which is the Startup on Tap, and 16th of April, which is Health and Nutrition 2020. So please see you all there too. Thank you.